Okay. Good day, everyone. My name is Olabi Adenio, and welcome to today's live coding session. And today we'll be doing a brief introduction of what Docker is. Um, as I've stated in this series, we are just doing a general introduction of DevOps. So we are talking about a lot of different concepts that are used in DevOps and what all of this concept means. So today we'll be talking about Docker. And as you must have heard me say in our previous sessions, Docker is a container infrastructure tool that can be used to um, move your code. It makes your code portable, but ensures that your code remains the same in every environment that your code is going to be placed into. So what am I trying to say? So it is a known fact that we have a lot of different operating systems. Some of us runs on Windows, some of us run on Linux. Some other people might run other variants of Linux. Some people use Mac OS also. So the way these different operating systems work is a bit different. For example, when you want to using file paths in Windows operating system, file paths in Windows operating system make use of forward slashes, while um, while file paths in Ubuntu and Mac OS they use sorry I mean Linux and Mac OS in general, they use backward slashes to show file paths. So these are like some of the very simple elemental differences that can happen, which makes it possible that when your code is migrated from one environment to another, your code might fail. Another very easy scenario that you can work with is, imagine we have three guys working on the same set of code or working on the same project, but one of them is using an Ubuntu system, the other is using a Linux, and one of them is using a Mac OS. So when someone using a Windows system writes some program, when he writes a program to um probably implement a function. When he's testing, he's going to write his test based on the architecture that his Windows operating system works on. So if that particular architecture is now something that has been changed in Linux operating system, then when the other guy that is trying to work on is trying to work on his own part of the code, but his own part of the code is dependent on the previous person, he will not be able to do so because the code will keep failing on his own end when he's trying to make some of these changes, or when he's trying to deploy, or when he's trying to test. So to take away all of these ambiguities that can occur, that's what containers are used for. Containers allow us to be able to create a pod. So that pod is encapsulated in that the pod is like an environment of its own. So you now deploy your source code in that pod with different, you add all of your different files, your different operating systems, and whatever your code needs to run. It will be placed in that visualization that we just made now of like a pod of what a container is. Then that container, when it is being moved from any system, when it is being moved from any environment, let's say it's moving from your own environment of a Windows PC to the environment of someone that is using Linux, because it will be running in that container, it is not dependent on the operating system that the host is running on. As long as they're just running it with whatever container orchestration system you are using, then you are sure that your code will work as expected, because in the container system, whatever it is that you have defined remains that way even when it is being moved. So to take a brief introduction to Docker, so I'll be sharing my screen now, and then we'll just visit the first thing. Okay, so this is a new tab. So I believe you can see my screen now. So this is Docker. So you can see Docker is a very popular tool, and most times when you see Docker, you see that it is very related with Kubernetes. So Kubernetes is something that work hand in hand with orchestration. So if you see Docker as a container, Kubernetes is a container controller. You can just abstract it that way. So Kubernetes is like an orchestration tool that helps you to manage different containers. So when your containers begin to get as much as possible, it is not wise to have to be operating all of these containers manually. Okay, anytime you want to make a change in one container, you have to do it manually. You have to go into the container. So as over the course of your coding session, you see how a container is, what it means. So if you have to keep doing all of this process over and over, it will just imply that you are wasting resources. So to not waste all of these resources, that's why we have something like Kubernetes, which is a container orchestration tool. And what Kubernetes does is that Kubernetes allows us to automatically manage containers. So with Kubernetes, we can decide to determine the point at which a container will be multiplied. That's something called load balancing. So all of these are things that are embedded in your course content currently, and as you go through it, you begin to find familiarization with all of these concepts. So let's go into Docker websites as a whole. So Docker builds now lightning fast. So discover Docker build class. So these are just things. So what is Docker? Docker helps developers build, share, and run and rev anywhere without tedious environment configuration. Exactly. So this is the major aspect of what Docker is giving us, because it enables us to not have to worry about the configurations that is needed to be done on probably a local system. So with Docker desktop, with Docker, or not only Docker, the other containerization tool, but Docker is the most popular. So with Docker, we don't have to care about whatever operating system a developer or any person working on the code is going to be using, because as long as the Docker environment is working, then no matter the system that the bare metal or the local hosts is having, your Docker is going to run as expected. So these are some of their stuffs, but we are not so we are going to go to their documentation. So get Docker. So these are their guides. So I'm just showing you, as I normally say, the best thing you can do when you are learning new concept like this is you have to like intentionally go through the documentation and concepts of all of these, go through documentation of all of these tools, because it's not something that we can just put the whole information at once. So we have to take it incrementally, step by step. So with Docker, there are two major ways in which you can use Docker. So you can either use Docker using Docker desktop, which is what you have here, okay, or you can use the Docker command line tool. So before now, you can, so this is the command line tool, the command line tool on the parent. So before now, the command line tool used to be the only method of using Docker, and even now, it is still the most preferred method, because um Docker desktop is like a graphical user interface um, representation of the CLI. So in most times when you have a graphical user interface for an app that is used in coding and programming, that program or that whatever tool that is will also have an equivalent command line tool. So whenever a user is probably trying to do this, maybe in a playing ground or in a testing ground, then you can use the GUI. But when you want to automate processes, and if you have, you should get the gist now that one of the main and core concept of DevOps as a whole is automation of processes. So DevOps aims to ensure that many processes that used to be done manually in time past are now automated. So when you want to use automation, you have to understand how the command line tool works, which is what you're going to be using most frequently. So I'll just be doing a brief showcasing of, so you want to get the Docker desktop, you can just come here and download it. But since I have the Docker desktop already, I'll just open it up on my system. So I'm going to change my screen that I'm sharing now to show us the Docker desktop. Share window, and then so this is the Docker desktop. So when you download Docker desktop and you install it on your system, so this is the interface you will see. Um, Docker desktop is a little bit tasking in the sense that when you are using systems or computers that are a bit old, it might take a while for your Docker desktop to start and it might lag on your system. So you can try to like you can try to download Docker desktop and probably check the specifications of your system to know if it's something that when you are running it on your system, you'll not be going into a lot of issues. In when we are going into Docker proper, we'll introduce you to a new life playground. So there's a playground, or probably I can even do that today. But I think in the next stage or two stages after this, we'll be going into Docker properly, and then we understand the fact that it might not be possible. Even Docker themselves understand the fact that not all computers, for people that are just in the learning process, can handle the burden and tasks required by Docker desktop. So they provide a playground where you can use Docker and write Docker functions and code without necessarily having to install it on your system. But today I'll be doing an introduction of the actual tool and what it does. Um so this is Docker desktop, and then so you can see the first thing we have here on the left is container. So containers is just as I've stated previously, containers exemplify what we mean by the hosts where your source code is going to be run. So on my own computer, you can see I have this container, I have this container. These are two containers that I have created previously, and in this live coding session, we'll also be creating one container, and you see what it means to have a container and like how your code are inside the container. So one of the very, very key aspect of Docker that powers almost everything that Docker does is image. So this is the aspect of the image, and under the image, every code you have created that you are trying to containerize, you first have to create an image from that code. So you have to like create an image, and it is in this image that you will specify all of the files that are meant to be in the container. It is in this image that you will specify the properties that the container is going to have when it gets created. So um let's say for example when you are, I don't know if you have some experience with TypeScript or NGNix for web development. So when you develop an app using these two TypeScript and you want to deploy, the standard routes or the standard process that you use to deploy. So the default port when you create an application with TypeScript is, I think it defaults to 5,000, port 5,000. But you have to manually change your TypeScript ports from 5,000 to 3,000 whenever you are deploying. So in when you are now trying to use a Docker container, you have to be able to like, when you have to tell the container, because a container will also have a lot of different ports. So you have to tell the container that this current application that I've written requires the port 3,000 to be open to the internet. So there's a keyword there, PORT, that's like port but all in capital letter, that we use to tell the Docker container. So it's in the Docker image. So that you see an example of all of this I'm saying, that we used to specify, okay, what are the properties that this container is going to have when it eventually gets created. So Docker images are like the backbone of everything that Docker exemplifies. Containers are just like built off of these images. So containers are just like access to your image. You can start a new container that will use that same image and have all of the properties and all of the files that a previous container contained. So that's what images are. On this aspect of volumes is what we use to store data. So because of the way Docker works, the way container works is that containers are not expected to live over a long period of time. So what am I trying to say? So let's say for example, in a workflow process, um you have like in an organization, we have a time logger where when an employee comes to work in the morning, they log in their time, and then when an employee is closing also, they also log in their time. So in this process, when an employee comes in the morning, and then the only thing we want to do is to record that, okay, an employee came at this point in time, let's say at 8 a.m. in the morning. That is when the employee came. So imagine you now have to, and the only time, let's say your employees, no matter how late they want to come, they don't come later than an hour. So your resumption time, or the time that you open for work, is 8 a.m., and then you don't have any employee that comes later than an hour, 9 a.m. So imagine, rather than having you have a dedicated computer to log all of these times. So imagine having a computer that will be on from 8 a.m. when you come to the office, for all of your workers to log in their time, and then from 9 a.m. till probably 6 p.m. when you are closing, that computer is just going to be wasting resources, not doing anything, because it has performed the function it wanted to perform around 8 a.m. to 9 a.m. So imagine the amount of resources that would have been wasted. That's time, power, because you use electricity power to power the machine. Your machine has to be connected to your servers. It's probably be connected to the internet. Probably the cost of operations and all of those stuff for just one machine that is doing nothing between the hours of 9 a.m. to 6 p.m., because you won't want to keep the machine turned off when it is time for the machine to work again, to log, probably when they are leaving, for everyone to say that, okay, this is my closing time, I'm leaving at this, at so point in time. So that is a lot of resources that have been wasted because it is just performing function. So what containers can do in this kind of aspect is, containers can help have, you can have a container where, when it is time to record the time that a user, as an employee, is present, the container comes to life, makes this record, and then immediately shuts back down. Another employee comes, he does the same thing, he comes to life, makes the record and persists it somewhere, and immediately shuts back down. So from 9 p.m., from 9 a.m., when there's no other employee that is coming late, till 6 p.m., you're not going to be wasting any resources, because immediately your container has done its job, it is going to what, get shut down immediately. But now that's where the issue comes. Imagine when your container is recording all of this time, it is not storing it to a database that is going to be persisted. So the memory on the containers, when the containers get shut down, everything in the container memory gets wiped off. It's just like, for example, when you have your local system turned on. So on your local system turned on, you might have some apps opened, you might have some files that you have not saved. All of these, you will always find them as long as the system is turned on. But immediately you shut down your system or you restart your system, some of these apps will get closed automatically, and you have to reopen them, or you have to reperform some of these actions before you get them to the state at which they were before. But immediately you perform these actions, as long as your computer is turned on, this state to be stored. So it's the same thing like a container. So what these volumes provide to us, volumes are a way where, when a container gets automatically, when a container like gets closed up, or when the container, the term we use is destroyed. When the container gets destroyed, the data that is in the container that you need to persist, the data in the container where you want this data to persist even after the container has been destroyed, we store this data in the volume. So that is what this volume here is for. And then the dev environment, Docker Scout, all of these are just extra tools provided by Docker for people to use. So to just show a very, very brief explanation of what Docker is, we'll just be creating and interacting with some images and some. Um, so I'm just coming up, trying to open up my Visual Studio Code where we'll be writing all of these. Okay, so Control Shift N. Sorry, 24, and then let me share my new screen. Okay, so I'm sharing a Visual Studio Code screen now. Can you just confirm that you can see my screen before I continue? Anyone, can you just like,
Please zoom out small.
sorry?
Zoom it out a little bit, please.
Oh, okay, yeah. When I start typing, you see, this is just my window. When I start typing, I'll zoom it. So,
All right, thank you.
um, before we continue, so I you remember I mentioned that Docker has both the Docker desktop, that's the graphical user interface that we just saw, and it also has the command line tool, the CLI. So if I come to my system, for any system, as long as you have Docker installed, the command line tool automatically gets installed, because the command line, the GUI is actually working based on the command line tool. The only difference is that the command line tool, there's no graphical progress or things that are associated with it. But with the GUI, it's like a more user-friendly method of using all of these tools. So if I come here and just type Docker, it will give me a list of different options. And this is what allows me that, okay, Docker is indeed installed on my system. So these are the different things. So you can say Docker run, Docker build, Docker pull, Docker push images, login, logout, and then management commands. So Docker compose, Docker container. So those are the kind of the different commands that you have available to you. So when you want to create a Docker file, when you want to create a Docker image, sorry, you need something that we call a Docker file. So if you come, as you can see on my left hand side, I just created something. Let me see, is there a way where I can zoom in? View, appearance. Okay, yeah, so I think this is zoomed in. So when you want to create an image, the first thing you need there is called a Docker file. So a Docker file serves as the basis of um you now defining everything that your Docker image is going to contain. So anytime you are defining a Docker file, the first thing you always need to define is a base image. So you can just think of it as this way. Imagine you had a laptop or a computer PC, and the computer PC does not have any operating system on it. Then there's no way you can work with that PC, because it is just hardware, basically. There needs to be a corresponding software that is supporting your hardware before you can perform some actions. That's why it's possible to use different operating systems on the same hardware. So on some systems, you see some people did at one point in time they used Ubuntu. When they needed Windows, they'll probably reformat or reinstall the system, but this time with a Windows operating system. But you also see some people that have used a lot of different Linux distros over the time before they found a particular one, but still on the same system. So if you are thinking of the Docker image as the hardware, everything in the hardware needs to have a software that is going to be dependent on. So for this, when you say a form command, the form command is where you specify, and the base image, this is where you specify the image that um your your container, or you can see it as your operating system, that your image is going to be working based on. So if we have a lot of different images, and then, well, you can see immediately I type Ubuntu. Ubuntu is one of the most popular base images that is used in Docker, because Linux is still one of the most widely used tool for web development, cloud infrastructure. As long as it has to deal with the World Wide Web or the internet, Linux is always one of the go-to tools, because it has been there right from time. It is open source, so a lot of people have access to it, can make tweaks that will still work with previous versions of Linux. So Ubuntu is one of the base most supported distros of Linux. So it is one of the most used base image for any for any for any Docker image, most of them that you see. So I'll say Ubuntu latest. Okay. So after you specify the form command, the next thing that we normally do is we normally create something called a work directory. So work directory implies that anytime, because for example now, you can, if you try to visualize your system for people that are using Windows, anytime you open your file manager, the directory you get directed to immediately is your work directory. Or you can also see it as your desktop. Immediately you turn on your system for Windows guys, and your system gets loaded in automatically. The first thing you see, where there are a lot of different files that you have saved there yourself, is your desktop folder. So your desktop folder serves as your work directory on immediate entry into your system. So trying to denote something like that in Docker, we also have the work directory key. So we use that to create a work directory that will be um, the source of truth or the source of entry for any for our container immediately it gets turned on. So you can use anything, but I'll be creating something called code as our work directory. So after you create code for your work directory, an absolute part. So let me just add this as an absolute part. Then the next thing you do is you copy your files, because when you are creating, just if you remember what we are saying, what you are trying to do is that you are trying to create a containerized version of your code that you have locally, basically. So when you are trying to create a containerized version of your code, you have to move your code from your local system into the new system. So that's why we are doing the copy. So you copy what this does. When you say dot, you are trying to say, okay, copy everything in the current folder that I am in my local system into, and when you say dot again, into the work directory folder on this my just created Docker image. Then when you are done, you have probably a run command. So this is just me trying to not overload us with all of this information, and then when we are focusing on Docker proper, we'll take more detailed and more advanced exactly keywords for Docker. So the run command, most times in the run command, you just let me just say the run command should echo started. Okay. So when this here is a basic inclination of what a Docker file is. So before the end of this live coding session, probably after this, I'll just switch back to Docker's webpage where I'll show you where they list out all of the tags that a Docker file can contain, and then what each of these tags mean, and how you can use these tags in whatever it is, in whatever Docker image you are trying to create. So after you are done with your Docker file, the next thing you should do now is you begin to use the Docker command line tool. So for when you are using the Docker desktop, it is not really easy to create a Docker image from the ground up using the Docker file in Docker desktop. So the command line tool still remains the widely accepted tool when you want to create a Docker image from the scratch. What the Docker desktop gives you is the ability to visualize your image after you have created it, or you can also use it to interact with Docker Hub where you can use other different images. So to create an image, what you just need to do is to say Docker, then you need to use the build command, build. So when you say the build command, then you need to specify where your Docker file is. So since I know that my Docker file is in this current directory where I am, the standard for representing your current directory in Linux or on the web or in over the internet is a dot, just one dot. One dot specifies that okay, this is the directory that I'm talking about. If you use two dots, it means a directory before. One dot is this directory, then two dots is a directory before. So if I say Docker build dot now and I press enter, you will see that some actions are being performed. So this is Docker trying to create an image based on what I've done. So because this is a very very simple image, it has been created. So for you to visualize my image, let me just probably um let me change my mode of screen share, and let me change this to the entire screen. So it's already on the entire screen. So now let me go back to my Docker desktop. So on the Docker desktop, if I now come to my images, you see that let me refresh this. You see that there's this thing here called none. It is dangling. It is none. So the reason why you are seeing this none here is because when I was creating the Docker image, I did not specify a name. So if you are going to be creating a Docker image, you need to specify the name of that Docker image when you are creating it. So if I go back to my Visual Studio Code now, and I'm going to do this. So to specify a name, you use the tag command. So that's like an hyphen and T. In full, the T means tag, and I'm going to be tagging this simple image. Okay, so if I tag this simple image now, I'm now going to run this again, and you see that this has been done, and now it's saying that
the image has been what? The image has been named. So it has renamed this image and it has named it simple image. So if I now go back to my Docker desktop here, you can see now that simple image has been what? Has been automatically has been created, and this is the image. Okay, so this is the image. So if I click on this image and let us see what is inside this image, you can just see that there are just 9 layers. So what are these layers trying to do? One thing you should just try and see is that you will see that some of the things that we wrote in our Docker file, you'll be seeing them there. The first thing is from. So from Ubuntu latest, we will not be able to see this because what this does is this downloads the Ubuntu operating system into our container. So when the Ubuntu operating system has been downloaded into our container, that's what so all of this here are. But you can see this part of work directory code. So work directory code here, which we have here, is after this image has been created, after you have downloaded all of your operating system, now I want to create a new working directory and let's call it code, and that was done. And you can also see that the copy dot dot that we did is also showing here. So copy dot dot, so it copies the previous folder, and then the last thing we have here where we say run echo started, you can see it here also. So it runs and it uses the bin command. So this bin command, all of these are Linux tools, and like they are very very, these are things that people that use Linux a lot will understand immediately. But this is like a shell, just like we have command line or the terminal or PowerShell on Windows. On Ubuntu, what they have is called the shell, it's either the shell or bash, while on Mac OS they just call it terminal. So these are like the tools that are used to run command line operations on your system. So this is our image. So let's try and run this image, and now from this image we are going to build a container. So let me say I want to create a new container. I'll come to this image, I'll select this image. So to create a new container, you click on run. So if I click on this one here, you can see what this is trying to say is that run a new container, and I'm going to be using this particular image to run this container. So I'll click on run, and you can see that if I go back to our containers, a new container has been created. It is this container here, and if I go into this container and let me try and inspect this container, you can see that okay, but I think it's part of files. So you can see that these are like the files in this container. But I want us to try and you can see the work directory code that we created. So this is the work directory code that we created. So this code that we specified there, immediately this container got created, this folder was created. And if you look at this Docker file, so what the only thing we have on in our current folder is the Docker file. And this Docker file got copied. And if you come here and you see it, you see if I try to open this file, I think exactly if I click on edit, you see that this file is exactly the same as what we have on our local system. So this is how the the image has been created, and in the image we have specified that we want our files that are currently on our local system to be copied into this container. So that's it. But then the part where we say echo, you can see that we are not seeing anything about that. I'm not seeing anything about echo because this container is not a container that is persisting. So this was what I was trying to say. You can see that the status of the container here is showing exited because immediately the container immediately the container comes up immediately the container comes up, it runs this command there, run echo, and immediately it runs this command echo. What does it do? It shuts down immediately. So the way containers work, Docker containers, is that once you have specified the list of things that they have to do, as long as there is no process that is a continuous process that keeps running, the container will get shut down automatically. So for example, using this now, so imagine rather than run, what we have here is log that so so and so person logged in at this particular time. So immediately it makes that login that this person logged in at this particular time, the container immediately gets shut down so that your resources are saved and you don't have any pending resources that is not being used. So that's what it does. So now let us try and do something here where um let's try and do something where we change some things. So let me add a new file here. I'll call this f1.txt. Okay, and in this f1 I'll say this is file 1. Let me save this. Let me also do f2.txt, and in this I'll also say this is file 2, and I'll save this file. So now before we create another one, I want us to go back to these images. You can see that for this image there's this thing here called tag. So what does this tag simplify? So just like the way in when we make pushes to our GitHub repository, or when we create a new code and we make a commit to the GitHub repository, the previous code there is overwritten, yes, but it is easy for you to refer back to a previous point in time. So what Docker is trying to do now is that Docker knows that it's possible maybe when you make a new change, you might want to revert back your changes. So if what you are doing is when you create a new image, everything in your previous image gets overridden, and you don't have a way to get back your previous state, this might cause an issue. Let's say because there's something called automatic rollback, in the sense when, let's say a feature, when you deploy this feature, you don't really like, or people that are using this feature have tested it and they've said this feature is not something that they like, and you want to automatically roll back your feature. If you don't have a way to reference your previous deployment environment or your previous container, let me put it that way, you will not be able to automatically go back because you don't have a source of reference. So what this tag here does is that with tag you are able to create the same image but different versions of that image. So just to show that, put that into context, let me come back here, and now let me create this new image, but now I'll be specifying a tag. So let me call this one, I'll call it tag 1. So when I do this and I run this, you'll see that our image has gotten created as expected. So the new image has been created. If I go back to our Docker desktop now, you'll see that now I have two different simple images. But for the tag, one is bearing tag 1 and the other is bearing what? Latest. So that is how you can create two different images from the same Docker file, but two of them will have different versions. So you can use any version you want. So let's say, for example, another way that you can do this is, let's say you are working, your organization is providing a service, and then you have a free tier service and a paid tier service. So the services that you offer for your free tier is embedded in one container, and then the services that you offer in your paid tier is embedded in another container, but it is the same service. The only difference is that in the free tier some services will not be available, meanwhile in the paid tier you have each and every service that you have available. So rather than having to use a lot of if and else statements, you can just have two Docker files created from the same image, where you will tag one as free and then you tag the other image as paid. So with this you can easily know that, okay, this is the container that is serving all of the free customers, and then this is the container that is serving all of the paid customers. So that's one way. And just like in our previous the previous one that we created, so this was the first image we created 9 minutes ago. If I go into this image, just like we did previously when we created the container from this image, so let me delete this container. Okay, now let me create a new container from each of these images. So let me create a container here, and
Please, I
then
was locked up by network. I can't see your screen again.
you can't see my screen.
Yes, I was locked up by network. I just came back. I've not seen your screen.
Can you see it now? Because I think I'm still sharing. Can you see the screen now? Hello, can any other person confirm if they can see my screen?
Yes, I can see your screen.
All right, thank you, Ayodeji.
Yes,
So Engineer Donald, probably you might have to check your network, or you can refer back to the recorded YouTube version for
sure,
more clarity.
sure. No problem. Okay.
Sorry.
Yeah, sorry, please, what was that notification at the club saying recording post?
No, 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 no. That's the meeting is being live streamed on YouTube.
I'm
So
okay. Yes.
after this session, you can see the recording on YouTube.
Okay, thanks.
Okay. Thank you.
Yeah, no problem. So going back, so let me create this container. I'll call this container, and I'll say from the first image. Okay. So let's run this container. Now let me come back to my images, and now let's create another container from the second image. So let me call this container second image. Okay. So let me run this also. So for you to see a difference between both of them, in the container for the second image, if you go to the files and we check this code, you see that our new txt files that we created have already been added. They were copied. But if we go back to our container for the first image, let's go to containers, our container for the first image, and we go to the files, you will see that if you click on this code, there is no txt file there. So because of when we created a new docker image, when these new files have been added on our local system, we created it with a new version. So when you create a new version of the image, the previous version remains exactly the same. So there's no changes occurring because you are making changes on your own local system. So your container system is separate and opposite, and your local system is also separate and opposite. So if I come here now on my look, I want to try and get, let me just go online and check for Linux commands. So I want something. Okay, let me try touch. Let me try touch. I want a Linux command that does not work on Windows. Touch. Exactly. So touch is not recognized on Windows. So now what I want to do is I'll go to our container that we just created. Okay. So but to do this now, I need to change something about this container. So let me create a version 3 of this container here. Let me come here. And instead of doing this, I will run it. Okay. So what we run is bin/sh. Okay. So what I'm trying to do now is I'm trying to tell this container that when you get created from this image, what you should do is you should show me a terminal. Instead of running echo and exiting immediately, I want you to open the terminal, and then with this I will be able to use the terminal on that particular container. So let me come here now, and I'll save this docker file. So I'll call this start2. Okay, so this has been created. Now let me go back to my docker desktop, and now from the images, so this is the simple image tab 2. Let me now create a container from this, and let me say container image 3. So let me run this. So if everything is working as expected, our containers or container image 3, but it is still exiting also. So I think that is not the correct command. Let me try and run this. Logs. Okay, so let me just um but this will be let me try this first and use cmd. Okay, so let me use the cmd. So cmd is another way for you to specify what you want to do on your docker container. So if you use the wrong command, the difference between cmd and run command is that the run command is what gets it gets done immediately before your container gets created. because you should get the gist now that okay, the first thing we do is we create images, then after we create images we then create container based on these images. So the run command is going to tell the container that immediately you get created, this is what you should do. But the cmd is an executable that after your container has been created, that is when the commands in the cmd will now get run. So in the run command it gets done before your container gets created, but the cmd does it after your container has been created. So let me create a new image now. And let me come back to the images. So this container, so let me create a container from this container image 3. So let me run this. So I'm running this and this is still not coming on as expected. So um, let me just check this. Let me just check this here. Um, run command. So there's like a CLI version, but I don't want to use the CLI version um because I don't want to use the CLI version because the CLI version means it will work on my local system. I want us to be able to do it on, but then let me just use the CLI version again. Let me just say docker run. So I'll specify p and then I'll specify the name of the image. So this is me not using I wanted to use the Docker desktop before, but it's seeming like it's an issue. So let me do this. Okay, that's not the test command. Docker run options. Container ports. Okay, so Docker run interactive, even if not attached. Okay, so I think that's what I need. So let me try this again. So exactly. So with this now, our docker container, if we go to our docker desktop, just to show you, you see that there's a container that we did not create ourselves, but the container is running. That's this container here, and the container is running based on the simple image tag too. So this container, if I come into this container now and check the files that are here, you see that the files, just because there's no change, code f1.txt. So if I come to this executable, so this is the bash of this ubuntu language, of this ubuntu basically. So just to confirm this, if I come here now, I was trying to show it earlier, if I use touch, you will see that touch will say touch is not recognized because in my windows does not know what touch is, but ubuntu understands what touch is. Now if I come here and say touch, you see that it is not giving an error the way windows is giving an error. So if I come here now and say okay touch, let me just touch, and I'll call this f3.txt, and I press enter, you see that on my local system there is no file that is created called f3.txt. But now let us go back to docker desktop inside this container, and then you can see that immediately there is showing modified. Our f3.txt has been automatically added. So if I come here now and edit this file, let me add this line of code here. Let me say this is file 3 and was created inside the container. Okay, so let me save this. I've saved this, and if I open this file now, So now let's go back to our terminal. Now let me do echo. Okay, echo f3 dot txt. It should be echo. Sorry, it should be cat. So cat is like all of these are Linux commands that you can just, if you go online and check Linux commands, you see a lot of different Linux commands and what all of them do. So cat f3 dot txt, and let me press enter. So you can see that the text that we created and added to this file here has automatically been added inside the container, but on our local system you cannot see this. So you can see that the container is separate from your local system. So anything you do inside the container, it gets stored in the container and it will be different from your local system. So if I create a new file in my local system too, it will not automatically showcase itself in that container or in the image until I specifically run the docker build command. And then to showcase the last thing before we end this live coding session today, let me stop this container. I think it should be exit. So I've stopped this container. Um, if we go back to this now, you see that this container, the logs, you can see that everything that we were doing on our command line, everything we were doing on VS Code, everything here, if you go back here, you can see that this is everything here. So your Docker desktop and your command line tool, they work hand in hand. The only difference is that your command line tool is giving you an easier way to visualize it rather than what your um what your command line tool is going to give you. So if I stop this container now, let me stop this container. Okay, if I stop this container and let me restart it. So this was the container, it is still stopping. This container was created from this image. Like I added a new file and I added a new text into that file. But just as I was telling you, this, if I restart this container now and say start, so this container is now running, okay, and I come to the files, you can see that the f3 that we added is still getting created because it is inside this particular container. But if I now delete this container, let me delete this container and create a new container still using this simple image of tab2 that we used previously. Let me create this new container and let me say cn, and I run this container. If you go into this container and check the files and we go back to code, you see that the f3 that we created and everything that we have done to the f3, it has been lost because it was only associated with that container. It was not associated with the image. So the only way you can do something where when you perform an action in a container is either you still have access to that particular same container, which most times is not possible unless you're on your local system or you are testing, is when you persist any change you are making to a volume. So um that's a very very brief introduction to what Docker is, how it works, what the Docker build file is. So in the next live coding session, we'll not be talking about Docker, we'll be talking about another tool. But all of these are just basic they are basic introductions because we are talking about DevOps in general, and DevOps in general is like is a tool that cuts across different areas. So when we get to each of these tools that I've been talking about, we did GitHub and Git Actions last time. Um, GitHub and Git Actions last time, and then today we have done GitHub Desktop, Docker Desktop. In next live coding session, we'll pick another tool. But all of these, they have their own stages as we go further, where we go deeper into all of these tools, into how they work and what we can use them for. So with that, we have come to the end of today's live coding session. You guys have a wonderful weekend. Thank you and bye bye for now.
Yeah. Thank you. Which tools are you looking forward to for next week?
Sorry, there's another live coding session that is meant to happen now, but we are looking at Circle CI for our next live coding session, or it could be Azure for cloud development. But in the next live coding session, we'll be showing a cloud tool. So this is what we'll be focusing on in stage E. So we'll have to exit this live coding session now for the next set of guys. So any further questions, you can direct it to me on Slack.
Okay, thank you. Thank you so much.